Okay, grade 11s, let's take a look today at our start with classes. Okay, to be honest, this is, in my opinion, the most important unit in the Java, in the grade 11 year. I said the methods unit would be your most useful unit, and I think it still is. Learning methods is incredibly useful as a programmer. But in terms of where you're moving forward, classes is like a concept that will go beyond grade 11, it will go beyond grade 12. This is what has revolutionized programming in a lot of ways, is this idea of classes and objects. Okay, it was on the very first day that I mentioned this word class, and I'm bringing back to it today. And you guys better be ready for this. Don't disappoint me, because I said this at the very beginning of the course. I remember drawing this on this board. A class is essentially two main things. What is one of those two things? Properties. Very good. Feeling good. Properties. And the other one? Functions, or, as we say in Java, methods. Okay, I'm feeling really good. You guys know your stuff so far. Excellent. A class is a collection of properties and methods. Let's use some other terms. What are properties? Well, properties are things about the class. And methods are things you can do with the class. Okay? So there's some general terms. Properties are things about it. And methods are things you can do with the class. So let's bring this to the world of your English class, okay, or your language arts class. A class could be thought of as a noun, right? Like an example would be a cat is a noun. So what are things about the noun, things about the cat? In English class, we would use a term to describe those kinds of words, like black cat or fat cat. What do those words black and cat mean? Like, what's the term for them in language arts? Words to describe a noun. Come on, you guys. Now you're letting me down. Those are adjectives. Holy, I hope you guys are taking computer science because all the English courses were full. Right? So adjectives are things about the noun. Now, let's see if you guys can redeem yourselves. Things a cat can do include running and jumping and scratching. What are those things described as in language arts? Verbs, right. Okay? So this is a couple different ways you can think about classes. Okay? So let's throw the example up there. A cat is a noun. A cat is a class. Things about the cat to describe it could include color. It could include size. It could include temperament, right? I know my mother's cat is very aloof. Verbs, things the cat can do. It can scratch. It can run, etc. So those are things that this noun, that this class can do with a specific example. But let's go to now the next level, because I've kind of introduced this to you guys already a little bit. But let's jump forward with this a little bit now. So now that you have this idea about classes with properties and methods, and we have a class, okay? We are going to write code to define a class. So let's say we want to make specifically a class called cat. And we will define its properties, and we will define its methods. And we will write what they are. And you guys know how to write methods. And really, properties are things like you know how to write methods that return, you know about parameters, you know all that stuff, hopefully. Properties are just things like variables. Or, if you want to go a little more complex than variables, arrays. So you know that these are things you could store about the cat. Like you could make an array of I don't know, color types that the cat could have. You could make methods, like a method called run and a method called jump. So we will be able to define what is class cat. But that does not make a cat. That makes, essentially, a blueprint, if you know what that is, for a cat. Another thing it could make is a recipe for a cat. When you get a recipe, like let's say you really, really wanted a chocolate cake. You just were dying for chocolate cake. Yet you didn't want to go to the store, and you thought, I'm going to try this. You could go online, you could find a recipe for a cake, and it could give you exactly what it is to define what's part of that cake and exactly what to do to make the cake. It'll give you everything. But you don't have a cake yet. You just have the recipe for a cake that you could use to make a cake. Similarly, let's say you wanted a house. You wanted to have your own house. You could find blueprints on making a house. You don't have a house yet, but you have the instructions. So a class is the blueprints or the recipe for building what it is you want to build. You will eventually use the class to create an object. An object is an instance of that class. So I could create a class or a cat called Fluffy. I could make Fluffy. Fluffy is a cat. So the class is the blueprint for building objects. So when I talk about classes and objects, I'm kind of talking about the same thing, but not quite. Classes and objects are slightly different. Objects are instances of the class. Okay, we're going to get into some fancy wording here. When you create an object, you are instantiating, there's the fancy word, you're instantiating that class. Okay? So this is a lot of theory. We're going to put this into code terms, but it's going to be very, very valuable for organizing your code and really taking your code to the next level, because this is where high-end programs come from, is organizing your code into modules or classes and objects that can be reused and can eventually make your programming really start to take off. Okay? So let's get started on just some of the theory here on classes. Okay, so, come on. Objects appear in the real world, okay? When you look at things like people and animals and cars and buildings, etc., we see them as specific objects. We tend to abstract our vision of the world in that way. So we see things and put them into categories, right? When you see people, you categorize them as people. If you see a horse, you categorize it that way. You classify it that way. It allows us to identify objects by creating classes for them. So this is a natural occurrence for us, is to abstractly put things into categories or classifications. And then we have subcategories within that. So when we see a beach, we'd classify it as a beach made up of other classes like sand, grains of sand. We see a forest, and we know it's made up of other objects called trees. We can do this quite naturally. So why not take this natural ability to classify things and subclassify things and turn it into programming? It's natural to us. So if we can make our programming do that, it'll allow us to solve problems in a way that's more natural to us. Now we can also divide classes into two categories: animate and inanimate. We can think of animate objects as things that are alive or things that move, and inanimate obviously don't. As well, we can then do what I just did, subclassify each class into attributes or properties and behaviors or methods. Okay? Object-oriented programming takes advantage of this by using this natural ability we have to classify things and turning it into real code. Okay? Now, when we create a class, like I showed you with the class cat, all objects of that class will share the same characteristics. So in other words, if I make a class called cat and then I make 5 different cats from that class, they'll all share those similar characteristics. Another way you could look at it, and this is my favorite way, is not a blueprint or a recipe, but that a class is a cookie cutter. You can use a cookie cutter to make lots of cookies. You can use blueprints. Like I can have blueprints for a house. Think about St. James itself. There's only really about 8 different types of houses in St. James. Some of them are mirror images of one another, but if you drive down any St. James street, you're going to see, if you live in a house in St. James, you're probably going to see a house just like yours if you drive around St. James somewhere. I mean, it may be painted differently, but the overall layout of the house, kind of like yours, okay? So some builder took a blueprint when they were building houses in St. James and built lots of houses of that same structure. Similarly with a recipe, you can build lots of cakes from that one recipe. You can build lots of cookies from that one cookie cutter. Each one will be its own individual cookie, but they'll all share certain characteristics. They'll all have the same shape. They'll all have the same size. So similarly, when we create a class in code, let's say we are building a game, and we make a class called enemy, we can use that class to build lots of enemies of all the same characteristics, okay? As well, when we get a little more advanced in classes, you're going to learn that classes also incorporate something from biology called inheritance, which is that one class can inherit traits from the other. Very similar to like biology and evolution, where you can pick up the traits, like you pick up the traits of your parents, which means that you'll be able to do the same kind of stuff that they can do, plus add your own characteristics to that as well. And this is a bigger concept we're going to look at in the later half of this unit that really makes classes, again, take off and become more useful to you. Okay? So again, let's say I had a class called person, and we're going to do this in our example. We make a class that has certain attributes and certain behaviors, and we could theoretically use that to inherit to a class called student that builds from there. Okay? And we're going to see that in the example that I'm going to write with you guys, how that works and how that applies. But we're going to do most of that next time. So we're going to stop there today. I know I didn't actually get to an example today, but we definitely will.